Hi, and welcome to our presentation where we'll be discussing displaying live environmental telemetry monitoring data with OpenGL Animation using the JavaScript API. My name is Janine Latham, and I'm the Geospatial Technical Director at Weston Solutions. Just real quick, Weston is a environmental and infrastructure solutions consulting firm, so we'll be discussing a solution that we've developed for our EPA emergency response client. I'll be giving you a brief introduction to the needs and challenges that our EPA client has to analyze and visualize their real-time sensor data, in addition to other operational data that are being made available through their JavaScript API-based web viewers. This discussion is also going to include how we're working with them to create efficient data management and workflow processes by leveraging real-time web services for mapping and graphical visualization. Then Josh Krochmal will walk you through the implementation and widget development in the JavaScript API that our principal developer, Long Ma, created to overcome these challenges. Just a quick note that since we submitted the abstract and created this presentation, Long has updated the solution to work in the JavaScript 4.18 API version, and that's the version that's going to be demoed later on in the presentation. Some of our work for our client projects require the use of mobile and fixed air monitoring instrumentation for data collection. So our EPA client specifically has a need to immediately determine off these monitors exceedances of health-based benchmarks and notify their users and the public of these exceedances in a near real-time informed way. An example site that they may have for an emergency response could be a network of up to 40 monitoring stations with, for example, 4 sensors at each station collecting 5 minutes on average, 24/7 for over 2.5 months, right? So this can generate more than 1 million readings of data that need to be reported through a public-facing or internal viewer in near real time. The size and real-time nature of this data present quite a challenge to manage and visualize effectively. To help alleviate this challenge, the EPA's Environmental Response Team, which we'll refer to as ERT later on in this presentation, has developed a telemetry system that allows their contractors and response partners to collect and store this massive amount of sensor data. So it's a wireless-based communication system designed to enable real-time transmission of data from the field sensors to a local computer, remote computer, or enterprise server and provide data management, analysis, and visualization in near real time. As contractors, we're given access through a data service subscription to this data to create ways to visualize and report this large volume of data through our JavaScript API web viewers. Here we have up on screen a look at an older iteration of how we would access this data to visualize it through our web maps and JavaScript API. So first, the data was passed from the instrument to a SQL Server database where it's compiled. Then that data is sent to a deployment manager for application, authorization, and distribution. Then this distribution of the OData feed is used to place the full data set into a secondary SQL Server instance for the project. Here, in this secondary SQL Server instance, SQL queries are generated using query layers for mapping through ArcGIS Server. From there, the ArcGIS REST endpoint, which only returns the latest reading, is consumed by the JavaScript API. This workflow, it was very data storage heavy, system processing heavy, and administration heavy. It also, delayed reporting by more than 15 minutes by the time the data made its way from the instrument to the web map. Sometimes it was up to an hour. So to enhance the way these data were being made available for web map consumption, ERT created a distributed JSON service through OData where a simple web query could return the latest reading, eliminating the need for the data to run through that secondary SQL Server instance and creation of that ArcGIS server map service or feature service, as long as we could figure out how to enable it for GeoJSON for mapping. So the improved workflow also exposed a JSON array from the OData that would give us access through, again, a web query to return the full data set for the given instrument and time period, again, to allow for that viewer access and dynamic charting, but also alleviating that need to bring that data all the way over to that secondary SQL instance. So next, Josh is going to take you through the widgets that we developed to do a real-time translation of that JSON to GeoJSON for mapping and charting capabilities in the JavaScript API.
Thanks, Janine. So as Janine mentioned, once the data workflow was updated so we didn't have to manage and manipulate such a large data set in SQL, it really changed how we worked with the data itself. Working with the JSON array really made things a lot easier. So now that we have a little bit of background on the data flow and some of the challenges, let's talk a little bit about the widget development. Here you'll see the widget development in JavaScript 3.x. And first, we'll call a secured service and return raw JSON from that live data feed. That JSON is then processed using the Terraformer JavaScript library to create JSON, GeoJSON, which is then added to the mapping application. Dojo FX is then used for the animation of that graphics layer. So let's take a look at that. Here you can see we have the data points loaded. That black point is a sensor that is not collecting data currently, and we'll turn on the data flashing. So that data flashing is set on an interval, and that interval basically determines when new data is retrieved. And that can be set to whatever length we desire. Clicking a point will just open up that pop-up. This demo does not have the formatted pop-ups, but there we go. And we'll clear the data. And refresh will bring back the data. All right, and turn those pop-ups off and just have the point itself. Okay. So now let's talk about the JavaScript 4.x widget development. Again, we call that same secured web service to get the raw JSON. But using JavaScript 4.x, we no longer have to use that Terraformer library to process the data. We can convert that dynamically into a feature layer and add that feature layer right to the map. So you'll see on the right here, that process we use to dynamically convert to a feature layer. And we'll use OpenGL for the animation for apps at 4.16 or above. So for this process, you can see that we skip that one step and streamline that flow a little bit. Let's take a look at the JavaScript 4.x version. All right, so first we'll open the widget and turn on the data. And again, we have that one black sensor that's not currently collecting data. And then once we have the data on, we'll click one of those sensors to open up the pop-up. So you'll see that just the pop-up is a little bit nicer than the previous version. Now we'll open up the attribute table. Attribute table is not much to look at itself, but I think the value here is the ability to download that data. Next, we'll pick a date, start and end date, a start and stop date for the charting. So once you have those selected, hit the graph button. Just take a second. And you'll see we get a couple different elements here, and they are independent elements. So we get a nice looking windrows over here on the left, which you can see is its own element, and you can export that. And then the chart of the sensor readings that you can also export. And then turn off the data and close the widget. All right. So hopefully you can see how that JavaScript version has really streamlined our workflow quite a bit. And if you have any questions, I know this virtual format is a little bit difficult, so please reach out to Long, Janine, or myself if you have any questions. Thanks.